Hello, I'm here to tell you a little bit about bamboo's function in the resilience of ecosystems. So, the few questions that I will answer in order to give clarity on bamboo's function in the resilience of ecosystems is firstly, why bamboo as a fast-growing plant assists in ecosystem resilience. Secondly, why bamboo as a water-holding plant or a water-retaining plant assists in resilience. And thirdly, why the structure and the anatomy of bamboo assists also in ecosystem resilience. So, answer to the first question is bamboo and its ability to grow very quickly. Now, the main function of bamboo to improve an ecosystem's functions is the fact that it can create shade very easily. And the fast growth of the bamboo is directly relative to its speed to which it can create shade. And underneath this shade, all other species within the ecosystem are protected. They are nurtured within the correct moisture content, the correct temperature, the correct wind speeds. It's let's say it's shielded from the externalities of this world that can be damaging to different species within an ecosystem, be it both flora and fauna. So I think that's the main function of bamboo from the perspective of a fast-growing shade and nurture for understory species. Of course, for canopy species, it can be seen as an auxiliary plant. So it can create a good shade and a good nurturing environment for other canopy species to grow. And then those species can also further assist for the canopy to create protection from external environment, from the external environment. Answer to the second question is bamboo's capacity as a water holding plant. Many scientists have talked about bamboo in terms of the fact that it is a C4 plant. It is like a water succulent. It actually is not a C4 plant, it's still a C3. It's still, how do you say, its water regulation system is still like a standard plant in the tropics. But its incredible capacity in its rhizome network, in its roots, to hold water in the soil kind of gives the impression that the bamboo has a very good water holding capacity. And this is mainly due to its net basket-like rhizomic network and also the expansion of the roots. So some people even say bamboo is like a surface, a topsoil aquifer. It's above your first aquifer. Bamboos can hold a lot of water, and many people around Asia, they say if you plant a bamboo, in 5 to 7 years after, you will have a spring that will come very near to that bamboo because it has this incredible water holding capacity within the soil surrounding the roots. And of course you have a lot of water that's held within the bamboo, but a lot of this evapotranspires to assist with the fast growth of the bamboo. So, answer to the third question. What was the third one?
3.
So, to answer the third question about how the structure and anatomy and physiology of the bamboo assist in the resilience of ecosystems. Basically, bamboo is like a hollow tube. It first of all, it's very carbon efficient. So with 1 ton of carbon, you can grow a lot more bamboo poles that send leaves into the canopy than with 1 ton of another kind of wood. So it's very carbon efficient because it's a hollow grass and a hollow reed. So it uses its carbon very efficiently. So that's one key concept that allows the bamboo to be able to have a very quick advantage over other plants within an ecosystem. And this can actually be a problem with many monopodial species, running bamboos, in the temperate climates, you know, in China, Japan, and actually in Europe now because it's been introduced. Because they run and they can kind of take over and be invasive. However, in the tropics, because it's a clumping bamboo, it doesn't have that same invasive potential. They clump. The mother and the offspring are very, very close together. So, so this allows the ecosystem value of the bamboo to be much more facilitating and nurturing for other species to grow with the bamboo. Now, at the microscopic level, also the bamboo is made up of hollow fibers, and it's you know, it has a thing called a vascular bundle, which is made of a metaxylem and 2 protoxylems, and there are many of these metaxylems and protoxylem vascular bundles, which allow for very good movement of nutrients and water, which means that basically the bamboo's capacity to take up nutrients and water is very efficient and very effective. And so this means that it can photosynthesize, evapotranspire, and basically bring more and more carbon, water, and nutrients into the living part of a forest or of any area that has plants growing.